using tables. So the premise here with an inverse function, if y is a function of x, then x equals f of y. You do x equals f of y, and then you solve for y, and you get y equals right here, and we refer to this as the inverse of f in terms of our functions. So y is a function of x. The idea here is that we switch, the idea would be like you switch x and y, and then you resolve for y, and when you resolve for y, you have what is known as the inverse function. Now, you can take derivatives of these type of functions, okay? So if the point x comma y is a point on this function, then it follows that y comma x, when we switch it, is a point on the inverse functions. More importantly, there's a definition of here and says that f of x and the inverse of f of x, sorry, I did not want to write it that way. Y equals f of x and y equals g of x are inverses if the following is true. So if I give you two functions, you can always define these two functions as being inverses, and this comes from your math 2, should come in your math 2, math 3, maybe even math 1. If f of g of x, if the composition of the two functions is x, or similarly, if g of f of x is equal to x. The idea behind an inverse is that it undoes the operations. So pluses and minuses are inverse operations, but 5 plus x, or x plus 5 and x minus 5 would be inverse functions, as when you combine them together, they would cancel each other out with the operations, and whatever you put into the function machine, you have the function machine, you put in x, out spits out f of x, and you spit that out into the other machine. This is function g, function f, function g. And if you did spit that out, and out spits out x, because you get g of f of x. And if you were just to get x, that means that it was an inverse. The two were inverse functions. So how does that help me? What does that do for me in regards to implicit differentiation and derivatives? Well, first and foremost, there's a rule. I have a hard time memorizing the rule, even myself. So basically what I do is I almost prove the rule every single time I do it. Now, of course, if the exam is open notes, then this is a derivative rule that you should just have available for yourself. And you can just look at it and memorize it. But I'm going to prove this one to you because it's very important, and of course it comes from the topic of implicit differentiation. First off, we're going to define g of x as the inverse function of f. It's easier for me to work with the g of x. So every time I write g of x, what I really mean is the inverse function, okay? And this proof. It's easier to see that when we're doing the work because it gets very convoluted if not. So we know that f of the inverse of f is x. So f of g of x will just be x. Now, if we were to differentiate both sides, like implicit differentiation, we take the derivative of the left-hand side, set it equal to the derivative of the right-hand side. We get f prime of the baby, which is g of x, times the derivative of the baby, g prime of x, it's just chain rule, is equal to 1. We now do some algebra to solve for g prime of x, and then we get that g prime of x is equal to 1 over f prime of g of x. That's the rule. However, if we want to write that a little bit more cleanly, or in terms of the inverse function operations, we say that the inverse of x, and then we can put a bracket around that, prime, the derivative of the inverse of f is equal to 1 over f prime of the inverse of f. And that is our rule. Right there. The derivative of the inverse function for f is equal to 1 over the derivative of the inverse function. As you can see, it's a fraction, and so that means, and here's one of the implications of a multiple choice. Most answers, not all, are going to be fractions. Okay? I'd say not all because you might get a fraction in the bottom, and therefore, you might get a fraction like 1 over 2, and therefore 1 over 1 over 2 gives you 2. It does happen, so it's not like an always or almost always ones. But I would say about 70–80% of the time, your answer for an inverse derivative for a function is going to be a fraction. Now, we could talk about many other functions that are potentially inverses, and talk about those ones, but they don't show up on the AP exam. We could go into a little bit more deeper in how this can be applied to implicit differentiation a little bit more in terms of just looking at the formula, but it doesn't show up on the AP exam. Basically, what you would do is you would take the derivatives. You would have to find the inverse function. There's a lot of different things that you can do. You can do the implicit differentiation. I'm going to show you that on Monday when we get back on November 30th for specific types of functions and how that kind of works. But it's a process that's really not covered in terms of teaching on the AP exam. Therefore, I just want to focus with the lesson of what you were going to be required to do, which is going to be evaluating inverse derivatives by tables. Now remember, one of the things that's going to confuse a lot of people is the difference between evaluating the function and evaluating the derivative. All right. There's a lot of people, a lot of places I get here that I'm like, yeah, you didn't really do any of the work. You can really shows through because your answer doesn't even make sense on step 1, or you didn't even take a derivative for these problems. So here in this problem, in this examples, we're going to use the following table: X, F, F prime, G, and G prime. Now, in this problem, I'm going to state that F and G are not inverses. Okay, F and G, you can also be given a table where F and G are inverses, but the focus on these problems is basically that F and G are not going to be inverses here. All right, because if they were inverses, if I wanted you to evaluate the derivative of G, there are some problems that can really do some tricky stuff to manipulate it. Okay. No, I don't go that far because it gets really tricky when you're talking about them being inverses. I don't think it shows up on the AP exam. I think they mostly show up like this. Most of the times they show up, there's not really an F and G. It's just like one function F, and that's it. 1, 2, 3, 2, 3, 7, 9, 4, 6, negative 3, pi, negative 1, 9, 2, negative 1/3. Now, something to note. F has the point 1, 2. So the inverse of F has the point 2, 1. The hardest part about doing these problems is reading the inverse. So typically we go to the left as my input, and then I read the value that's in the table as my output. But if I said, hey, what is the inverse f of 2? So in other words, the inverse f of 2 is 1 because f of 1 is 2. All right? The inverse f of 2 is 1. Why? Because f of 1 is 2. They switch places. The x and the y switch values, which I was referencing earlier on in the lesson. Questions? No questions, all right. It's problem example A. Find the derivative of the inverse of g at x equals negative 3. Now this is always interesting because people go, well, there's no x equals 3 or negative 3. There's x equals, did you mean x equals 3? I mean, like, no, it's the inverse of negative 3. Okay. Now, it should be noted that the inverse g of negative 3 is what? What is the inverse g of negative 3? It's just a number. I'm just asking to evaluate. If I ask you, it's 2. Yes, correct. It's just 2. All right. G of 2 is negative 3, so inverse g of negative 3 is 2. But that's not the answer. That's not what I'm doing. All right. Some people are just going to, I have some people, and it's always like, it astonishes me. I'm like, wow, you really did not pay attention at all because you didn't do any attempt at any calculus. They'll say, oh, the answer is just 2 to this problem. They don't even take a derivative, right? So we need to take a derivative. Well, the derivative of this function, the derivative of the inverse g of x is equal to, and we just go to the formula. It's 1 over g prime inverse g of x. Now, I am always a big proponent of first writing the derivative function because sometimes on the AP exam, you get points for writing the derivative function and then plugging in the number. With table problems, I am also a proponent. I also recommend that you do this as 2 separate steps just to make sure that it's done right and also to make sure that you're given full credit. In other words, and I wrote it that way, but I could have also written it as prime like this. Inverse g of negative 3 prime, which is derivative, is equal to 1 over g prime of inverse g of negative 3. And now it's just evaluating. That's the only part on the calculus is the formula. Really, the only part of the calculus is the formula. That's it. And now technically it's an algebra topic. It's an advanced algebra topic of reading the table, of using the table that we have to find the answer. So this gives me what? Taking me step by step. What do I get next? What do I evaluate first? The rules of evaluating are still the same. It's still PEMDAS. Evaluate what's the closest thing inside the parentheses. So what am I evaluating first? I've heard Ariana. Is anybody else out there? Negative 3. Well, the negative 3 is the closest thing in the parentheses, but that's part of an operation. So the operation is what's attached to it, which is that g of negative 3. So we just noted that inverse g of negative 3. We noted that was 2 because right here we go backwards when we evaluate inverses. And so this becomes 1 over g prime of
2. Yeah.
2. Good. And now I just go to my table. So what do I get as my final answer?
Would it be 1 over 2 pi? Yeah, it's pi.
It'd be 1 over pi. So g prime of 2 is pi. So I just get 1 over pi. And that's my answer. Do another example. And let's make this example a little bit more intense. So in this one right here, we're using, first off, we're using the same table. Okay. In this example, I'm actually going to do a whole tangent line. I want to find the equation of the line tangent to h of x at x equals 4. So in your homework, I'm going to label this as, I'm going to define these functions of h of x. And so h of x is 5 times the inverse f of x. So now, right now, these first two examples, I'm just doing problems that are very straightforward of, these are basically either the inverse functions or constant multiples. In the next example, I'll go a little bit more difficult. All right. What is this question asking me for?
Equation of the line tangent.
Perfect. And therefore, when I get that type of question, my recommendation is always to write what?
The line. Oh.
Mm-hmm.
Go. Oh, y. Go on. F of A.
There's no f. It's not. We're not finding a tangent. It's asking me the tangent to h of x.
Oh, it's y1. It's not the two lines.
No, it's not. No y. There's no y ones. It's the tangent to h of x. And we don't use the y minus y1 in AP Calculus ever. Y minus.
Would it be f of a or would it be h of x?
It's never h of x. It's never h of x. That would be very bad. It's not of x. That would be very bad because that would not give you a line. H of 4. H of 4. Very different from h of x. I get students that do h of x and I go, oh, I knew what you were talking about. And then on the next line, they literally write in h of x, which is very bad. So they don't know. So you need to be specific to the problem at hand. So it's not h of x, it's not y1. It's you would on our typical formula we're finding the tangent to f of x, so that's why it's f of a. If you wrote a on here, if you said h of a, that would have been appropriate as well, but a is 4, so might as well plug in the 4. Equals
H prime of 4
times the quantity.
X minus 4.
Perfect. And we need to find h of 4 and h prime of 4 and replace those two values, and then we have the equation of the tangent line. So it's like the same problem where you have to find h prime of 4 and then h of 4. I like to find h of 4 first. Here's why I like to find h of 4 first, because we might need to utilize that in later on in our problem. All right, so I'm going to find h of 4 first. So h of 4 is equal to 5 times the inverse f of 4. Okay, well, go to my table. What is the inverse f of 4? Hmm?
3.
No, not 3.
2.
2. Yeah, 2. F of 2 is 4, so inverse f of 4 is 2. Right there. You got to be able to get that part. So this just becomes 5 times 2, so h of 4 is 10. Okay? So in other words, your final answer is going to be like y minus 10. We also want to find h prime of 4. But to find h prime of 4, I need to first find h prime of x. So using the formula that we've just used, that we've just learned, what is h prime of x? Now 5 is a constant multiple. All right, so how will my derivative look like? And I've already given you the derivative of the inverse f. I've written that formula down. Now this is just 5 times the derivative of inverse f. So what is my answer for the derivative function?
Would it be 1 over?
It's not.
Or we have you would have the 2, and then would it be?
There's no 2. I said I'm looking for the function first, but I don't want you to give me the answer for h prime of 4 first. So we're trying to find h prime of 4, but before we try to find h prime of 4, we need to first find h prime of x. It's very important to find the function first before we find the value. Always do that process. And I heard you say 1, but you got to be careful. It's either you want to either write the answer as 5 over or just do 5 times. All right, don't forget the 5 that's inside this derivative. So 5 times what? What's the formula? You just got to regurgitate to me what I've written for you. And you can't type it really. Someone needs to speak out. What is the formula that I've shown to you today that you will have to reference over and over on tonight's homework?
1 over f prime parentheses f minus, or f the inverse of x.
Perfect. It's just 5 times, which is the same thing as just 5 over. It's the same thing as just 5 over. But if you want to leave the 5 on the outside and clean it up at the end, it doesn't matter. But some people will write it as 5 over, and some people do 5 times. I like to do 5 times. All right, now we need to find h prime of 4. So h prime of 4 is 5 over f prime inverse f of 4, which is 5 over f prime of We already found this.
2.
2. Which gives me 5 over...
Would it be 6?
6. Which is 5 over 6. It gives you my final answer, y minus...
Times
equals
5 over 6
times,
x minus 4.
and that's it. Done. Think we got time? Yeah, I think we got time. Time for 2 is what I'm saying. So h of x is equal to, we'll go x squared times the inverse x of 2x. Find h prime of 1. Yeah, that'll work. So this one I'm not asking the whole tangent line. All right. Those tangent line problems take a little longer, but the process is the same. I just want to make sure that we can do the process of them for at least one problem. You got to write down the tangent formula correctly, first and foremost. If you're not writing tangent line formulas by now, you really got to make sure you put in that extra legwork because you got to write the tangent line formulas correctly. There is no passing of the AP exam. I can tell you and guarantee you that if you can't write the equation of a tangent line. It's one of the most important things that just happens over and over and over and over in this course. So make sure that you're working on that ASAP. All right, so what do I got to find first? What do I do first on this problem? What do I got to find first in this problem?
H of 1?
No. We will eventually have to find h of 1, but that's a coincidence, or that's just part of what's going to end up happening. What am I going to find? I got to find, the question is find h prime of 1. So I need to know that when a question says find h prime of 1, I need to find, thank you, Mana, I need to find h prime of x. Okay, so that's always the one thing what you want to do when you want to find h prime of a number, h prime of a, you first find h prime of x. Why is this problem so much more difficult? What is the premise of h of x? What method do I have to use?
Chain rule?
Before I get that, it's before chain rule. This is a product rule. U times v equals u prime v minus v plus v prime u, and then after that, I need to note that v is a chain rule. So this has product rule and chain rule built into it. So this is my U and this is my V, but there's also a baby within my G, within my V part. Okay, so I just have to chain rule that. I just have to chain that when I take the derivative. So this one is a problem that it might be beneficial, and let me actually change the colors on these ones. Make these blue. This is U, this is V, this is the baby. So I should probably find what is U prime on the side. So what's U prime? Everybody should be getting that instantly and trying to shout that one out. I can tell you that much. It's just 2x. Thank you. And V prime is, now there's a 2x in there, but right now I'm just going to ignore the 2x in my initial part. So what is the derivative here? Now let's see if you can find a derivative. If it wasn't just a 2x and it was just an x, what would I have done?
I probably did this wrong, but I did like 1 over G prime parentheses G, the inverse of G of 2x, and then times 2.
Correct. And I want you to note that the times 2 is actually, it's not in the denominator. It's that whole thing times 2. So the 2 is not down below. The biggest mistake I see people make on this one is they put the 2 down below. So it's going to be 2 over rather than 1 over 2 times. Okay, so yes, you did it correctly. All right, so with that, I can now find h prime of x. So h prime of x is u prime. So bracket times parentheses plus bracket times parentheses. So u prime is 2x times v plus v prime times u. And now I can find h prime of 1. H prime of 1 is going to be 2 times 1, which is 2, times inverse g of 2, 2 times 1, plus 2 over g prime of inverse g of 2, times 1 squared, which is 1. I plugged in the 1. That's all I did. What is inverse g of 2? No. What is inverse g of 2?
3.
3. Inverse g of 3. Inverse g, not g. So this gives me 2 times 3 plus 2 over g prime of 3, which gives me 6 plus 2 over what's g prime of 3. What's g prime of 3?
Mr. G, can you repeat what you said?
What's g prime of 3? Thank you, Norda. Thank you, Norda. It is negative 1/3. Just reading the table. No calculus involved. G prime of 3 read the table, negative 1/3. So that gives me 6 plus keep, change, flip, which gives me 6 minus 6, which is 0. I always love that problems when you do all that work and the answer turns out to be 0. Which also means technically that we have a horizontal tangent at x equals 4. Ooh, or x equals 1, sorry. Okay, I just realized that should have been example C. Yeah, we have time for one more. H of x equals the natural log absolute value inverse f of x squared. Find h prime of 2. Okay. This is as difficult as it probably gets. Double chain rule is technically what's in this problem. So the first thing I need to find, as we've already gone over, I need to find h prime of x first. And when I find h prime of x, I got to realize that what type of problem is this? What is the outer?
It's like a multiple chain rule.
It's a multiple chain rule, but yeah, so it's multiple chain. And working from the outside in, I first have a natural log. Then I have inverse f. Then I have x squared. Okay, so we like to work on our way from the outside in. All right, so let's work with the natural log first. So h prime of x equals, what's the derivative of natural log?
1 over.
1 over everything to baby. Yep, so what is it?
Your inverse of f of x squared.
Good. Times the derivative of the inverse. And if for notes purposes, I like to do it like this. You need to find the derivative of that. All right? So 1 over the baby times the derivative of the baby. So now that gives me h prime of x equals 1 over the inverse f of x squared times, well, what's the inverse? What is the derivative of the inverse of f? What is the derivative of the inverse of f? Should be very easy by now. We've done this already 3 times.
It's not negative 1.
No. There's no negative. Somebody speak. Just repeat the formula for me. What is the derivative of the inverse of f?
Oh, isn't it like 1 over f prime of f inverse of x squared? And then you gotta put to the side times your 2x.
So Ariana also went through and said, oh, x squared, so it's not of x on the bottom, it's x squared, and she went forward with the chain rule and did the 2x as well. All right? So if it was just inverse f of x, it's something that you should be able to copy and just look at your notes by now. It would have just been 1 over. So that's my derivative. That's a really good problem of really challenging and checking yourself at this point in time. Can you do chain rules? Do you understand the process of chain rules? If not, get some more practice. Make sure you're going to office hours. Make sure you're going to tutoring. If you need to continue and do those correctly, they need to be done correctly. So h prime of 2 would be 1 over inverse f of 4 times 2 times 2 over f prime inverse f of 2 squared, or which is just 4. Okay. Which gives me 4 over, well, what's the inverse f of 4? What's the inverse f of 4? Yeah, 2. Same, we already found that earlier. 2 times, I think this is going to confuse people the way I'm doing it. I think it already is. I'm going to go 1 over 2 times 4 over, you could have just put the 4 in the beginning, but I think people want to see it separately. F prime of 2, which is 1/2 times 4 over, well, what's f prime of 2?
6.
6. Which gives me 4 over 12, which is 1/3. So that's derivatives of inverses, utilizing tables. I like table problems. I want to note that there's a lot of little places that you can make mistakes. I make the mistakes even when I do my solutions of these type of problems. I read the table wrong. So sometimes that happens. That's not as big of an issue as making sure that you can do the processes correctly. Seeing that this, like for example, that this problem is a multiple chain rule. Recognizing the babies, recognizing that the derivative doesn't have absolute values, recognizing the inverse f aspects of it, recognizing that to read a derivative of an inverse, you have to go backwards within the table. Sometimes you look at the wrong line. I've done that before. I look it up and boom, I look over and I'm on the wrong line. But because I showed my work, I know that it was pretty much done all the way correctly. We call that a transcription error. That has happened. It's not much of a big issue rather than not doing the material correctly. That's all I have for you for today. Tomorrow is a check-in day.